One morning, astronomers notice something wrong. Neptune isn't where it should be. The math says it should be here, but the telescopes say it's there. A tiny discrepancy, probably instrument error, except it's not. The next night, Neptune is even further off course. And now, Uranus is drifting too. Something out there is pulling on the outer planets. Something massive that we never saw coming. Over the following weeks, the anomaly becomes undeniable. Saturn's moons begin shifting. Jupiter develops a wobble. The entire outer solar system is being tugged towards something invisible, in the darkness beyond Pluto. When scientists finally confirm what it is, the news spreads fast. A rogue black hole has entered our solar system. And for most people hearing this, something doesn't compute. Because when most people picture a black hole, they probably picture something stationary. A cosmic drain fixed in one spot, sitting at the center of a galaxy, waiting for things to fall into it. Not circle a star the way planets do. They just drift through the galaxy with no anchor, no orbit, and no predictable path, moving through the darkness at tens of thousands of miles per hour. Scientists have known about rogue black holes for years, and now one is here. This hasn't happened, but it could. And we'd have almost no warning. And here's the part that should unsettle you. There might be 100 million of them in our galaxy alone, and we just can't see them. So where do these things come from? How does a black hole end up homeless and drifting through the void with nothing holding it in place? It starts with a death. When a truly massive star runs out of fuel, it doesn't fade away quietly. The core collapses in on itself so fast and so violently that it punches a hole in the fabric of space. What's left behind is a region where gravity has gone insane, where the pull is so strong that even light can't climb out. That's a black hole, and normally it stays where it was born, anchored by the gravity of nearby stars or the galaxy itself. But sometimes the collapse isn't clean. If the implosion is slightly uneven, the newborn black hole gets kicked. Like a bullet fired at an angle, the explosion that created it also launches it, sending it flying away from its birthplace at ridiculous speeds. Other times, two galaxies collide. Their central black holes interact, whipping around each other in a gravitational dance until one gets flung outward like a stone from a slingshot, ejected from its home galaxy entirely. However they're made, the result is the same. A black hole with no address, no orbit, and no leash. Just momentum and hunger, wandering the galaxy for billions of years. And the scary part is how many there might be. Current estimates suggest our galaxy contains somewhere between 100 million and a billion stellar mass black holes. That's black holes formed from collapsed stars, typically 5 to 50 times the mass of our sun. A significant fraction of those are probably rogues, unanchored, and wandering. We've only detected a handful, maybe a few dozen confirmed. The rest are invisible. A black hole only reveals itself when it's actively eating something or when it passes in front of a distant star and bends the light in a way we can measure. Otherwise, it's just darkness, moving through darkness. So let's talk about what happens when one of these invisible wanderers aims itself at our solar system. It doesn't announce itself. There's no flare, no signal, and no cosmic warning shot. The first sign would be exactly what we described at the start. Something wrong with the outer planets. Neptune's orbit stretching slightly. Uranus drifting off its expected path. Maybe some of the smaller objects in the Kuiper Belt behaving erratically. Scientists would notice the math not adding up, and they'd start looking for explanations. At first, they'd probably assume it's an undiscovered planet hiding in the outer solar system. Scientists have been hunting for a hypothetical Planet 9 for years anyway. A massive planet lurking beyond Neptune that could explain certain orbital oddities. But the numbers wouldn't fit a planet. The gravitational influence would be too strong, too concentrated, and it would be moving in a way that planets don't move, not orbiting the sun, but passing through, like a bullet cutting across the highway. By the time they confirmed it was a black hole, we might have decades of warning. Maybe a century if we're lucky and it's approaching slowly. Maybe less if it's moving fast. But here's where the hope dies. There would be absolutely nothing we could do about it. You cannot fight a black hole. You can't blow it up because there's nothing to blow up, and you can't push it off course because the energy required would exceed everything humanity has ever produced combined. All we could do is watch and calculate, figure out how close it will pass, and hope the answer is far enough. But what counts as far enough? A black hole doesn't need to hit Earth to kill us. It doesn't even need to enter the inner solar system. Its gravity reaches out across millions of miles, tugging on everything in range. Here's something that might surprise you about the size of what we're dealing with. A black hole with 10 times the mass of our sun would be physically smaller than a city. Maybe like 60 kilometers across. You could drive across it in under an hour. But those 60 kilometers contain the gravitational pull of 10 suns, crushed into a space smaller than most countries. Physically tiny. Gravitationally monstrous. If that 10 solar mass black hole passed through the outer solar system, say around Neptune's orbit, the effects would ripple inward. Neptune and Uranus would have their orbits dramatically altered, stretched into long ellipses, or ejected entirely. Some of their moons would be flung into interstellar space, and the disruption would cascade. Jupiter and Saturn would wobble, their own orbits becoming less stable over time. The asteroid belt between Mars and Jupiter would become chaotic. Millions of rocks, suddenly untethered, tumbling in random directions. Some would be flung outward into deep space. Others would fall inward, toward the inner planets and toward Earth. Asteroid impacts would become a secondary threat, with debris shaken loose by a gravitational intruder we couldn't stop. But the real danger to Earth isn't the debris, it's our orbit. We exist in a very specific sweet spot called the habitable zone. Our distance from the sun allows liquid water to exist on the surface. A little closer and we'd boil. A little farther and we'd freeze. This balance has held stable for billions of years because our orbit is nearly circular and nothing has come along to disturb it. A passing black hole could nudge Earth out of this zone. Even a small change to our orbital path would have massive consequences over time. Summers getting longer and hotter. Winters growing colder, ice caps expanding or melting entirely, climate systems that evolved over millions of years thrown into chaos. And that's the gentle version. If the black hole passed closer, say inside Jupiter's orbit, the effects would be more immediate. Tidal forces from its gravity would stretch the planet itself. Not enough to tear Earth apart at that distance, but enough to trigger earthquakes along every fault line simultaneously. Volcanic activity would spike as the crust flexed and cracked. The moon might be stripped away entirely. Without the moon stabilizing our axial tilt, Earth would wobble like a broken top. Seasons would become chaotic over thousands of years. The northern hemisphere might tilt toward the sun continuously for decades, baking half the planet while the other half freezes. Then it would flip. The climate zones we've known for all of human history would become meaningless. The planet that survived the black hole's passage would no longer be the planet we know. And in the worst case, if the black hole passed inside the moon's orbit, Earth wouldn't survive at all. Tidal forces at close range would stretch the planet like putty. The side facing the black hole would be pulled harder than the far side, and the difference would tear the world apart. Earth would be shredded into a stream of molten rock, spiraling down toward the event horizon, stretched and superheated until nothing recognizable remained. No explosion, no dramatic collision, just a planet being pulled apart like taffy, swallowed by something we never saw coming. So, why haven't we been hit already? Space is big. Like, incomprehensibly, absurdly, mercifully big. Even with 100 million rogue black holes wandering the galaxy, the distances between stars are so vast that the odds of one passing through any given solar system in any given million-year period are tiny. Space is mostly empty, and black holes are small targets moving through that emptiness. The Milky Way has existed for over 13 billion years. In that time, plenty of solar systems have probably been disrupted or destroyed by passing black holes, but plenty more have survived untouched. The odds are in our favor. Probably. The problem is that probability isn't a shield. It's just a way of describing our uncertainty. We don't know where all the rogue black holes are. We can't track their paths. One could be heading toward our solar system right now, still centuries away from arrival, and we would have no way of knowing. We only spot them when they reveal themselves, when they eat something bright or bend the light of a background star at just the right angle for our telescopes to catch. For every black hole we detect, there could be thousands more moving through the void unobserved. In 2022, astronomers confirmed the first definitive detection of an isolated stellar mass black hole using a technique called gravitational microlensing. It took 6 years of observations to confirm what they were seeing. 6 good years to identify one black hole. And there might be a billion more out there. Here's how they found it. A black hole passed between Earth and a distant star. For a few hours, the star's light bent around the black hole's gravity, brightening and dimming in a specific pattern. That was it. That's the only sign. A flicker in the darkness, lasting hours, visible only to telescopes sensitive enough to catch it. If you weren't looking at that exact spot at that exact moment, you'd miss it entirely. We're not blind, but we're close to it. So, what do we do with this information? Honestly, nothing. There's no preparation that helps. No bunker deep enough, no spaceship fast enough. If a rogue black hole enters our solar system on a collision course, we observe it, and we wait. That's all. Maybe, with enough warning, someone would propose evacuating to another star system. But the engineering doesn't exist, and might never exist. And even if we escaped, we'd be refugees in a galaxy where the same invisible threat lurks everywhere. Every solar system faces the same odds. There's nowhere to run that's actually safe. The galaxy is full of these wanderers. Most will drift through the void for billions of years without passing near anything interesting. Some will disrupt solar systems we'll never know existed. And maybe, someday, one will drift a little too close to ours. We probably won't see it coming. We definitely won't be able to stop it. And the universe will continue on as if nothing happened, because to the cosmos, one more solar system going dark barely registers. That's the reality of rogue black holes. Not malevolent, not hunting us, not even aware we exist. Just mass and momentum moving through the dark. And somewhere out there, right now, one of them is on the move. If this made you look at the night sky differently, hit that subscribe button. And I'll see you in the next one.